Section 2. Density, specifically latent heat and specific heat capacity calculations. So we write out the three equations. First one is density equals mass over volume. Second one is energy equals mass times specific latent heat. And the third one is energy equals mass times specific heat capacity times temperature change. So what does each letter stand for in the units? Rho is density, Greek letter rho, and some questions density will be in kilograms per metre cubed, some questions it will be in grams per centimetre cubed. Mass is standard unit is kilograms, but again in some questions you might get it in grams, and volume is metre cubed, sometimes centimetre cubed depending on the question. E is energy, measured in joules. L is specific latent heat. Measured in joules per kilogram. And C is specific heat capacity, measured in joules per kilogram degrees C. And theta, Greek symbol theta, is obviously temperature change, and that's measured in degrees C. So low demand questions, very straightforward. You're just doing density equals mass over volume, and you just put your numbers in. So it's 200 divided by 0.7, and that comes to 2857. Try and get into the good habit of bugging the equations. So you put a box around the quantity that the question is asking you for, and you underline the given value. So you're given the mass, you're given the specific latent heat, you put your numbers in, multiply them together. So your mass is 0.4 multiplied by 291000, and your answer is 116400 joules. Third one. How much energy is needed to heat a 0.8 kilogram block? So you've got your mass, you're given the temperature rise, and you ask for the energy. You're also given the specific heat capacity. So you're using E equals mc theta, and you put your numbers in. So your mass is 0.8 multiplied by 900 multiplied by the temperature change, which is 30, and your answer is 21600 joules. Standard demand questions. You've got to know the equation off by heart. So you write out the equation, density equals mass over volume. You bug your equation, so you put a box around the quantity that's asked for, underline the given values, so you're given the volume, you're given the density, and because density is in grams per centimetre cubed and your volume's in centimetre cubed, you don't have to do any unit conversions, you can just do the mass in grams. So the density is mass over volume, you're given the density 7.8 equals the mass that you don't know divided by the volume, which is 48. So to find the mass you do 7.8 times 48, and that comes to 374.4 grams. Okay, the next one, using the same equation, density equals mass over volume. So this time you're calculating the volume, you underline the density, you underline the mass, and again, density is in grams per centimetre cubed, mass is in grams, so your volume can be in centimetre cubed, no unit conversions needed. So you put your numbers in, 2.75 equals 4.5 is the mass divided by the volume. So you've got to find the volume. So some people find this a little bit tricky. I'll show you how to do it in two stages. So you've got to get the volume by itself. So you could multiply both sides by V to start with. So you get 2.75 times the volume equals 4.5. And then to get V by itself, divide both sides by 2.75. So your volume is 4.5 divided by 2.75, and that gives you an answer of 1.6 centimetre cubed. Okay, so question 6 is about specific latent heat. So you write out the equation for specific latent heat, and that's one that is given to you on the data sheet. Bug your equations, so put a box around energy. You've got the mass is 0.25 kilograms, and you're given the specific latent heat of fusion. Be really careful with this one, because the specific latent heat is 334 kilojoules per kilogram. That is the same as 334,000 joules per kilogram. So you might want to write that in there and then. And then you just put your numbers in. So 0.25 times 334,000, and that's going to give you an answer of 83500 joules. Question 7. It's about specific heat capacity. So you write out the equation for specific heat capacity. Again, that's given to you on the data sheet. So bug the equation, calculate the temperature change. So that is theta that you're going to be finding. You're given the mass, 2 kilograms. You're given the energy, 20,000 joules, and you're given the specific heat capacity. So you put your numbers in. Always write out the equation, then put your numbers in, and then you rearrange last of all. So 20,000 equals the mass, 2, multiplied by the specific heat capacity, 385, multiplied by theta, the temperature change. So you want to find theta. To get theta, you're going to do 20,000 divided by 2 times 385. And when you work that out, it comes to 25.97, or let's round it up to 26 degrees C. Okay, so this one's a little bit more complicated. This is a standard stroke higher question. So you've got to calculate the mass of a block of marble. So bug the equation, put a box around the word mass. You're given the dimensions of the block, so underline those, and you're given the density. And it's also asking for your answer to 2 significant figures. So you know that you're going to have to use the density equation, but which you know is density equals mass over volume, but you've got to work out the volume. So your volume is going to be 2 times 3 times 5, which is 30 centimetre cubed. So you've worked out your volume. Now put the rest of the numbers in. So your density is 2.64 equals the mass divided by 30. So your mass is going to be 2.64 times 30, and that comes to 79.2. But you've got to remember that the question is asking for 2 significant figures, so you write 79, and the units is grams. No unit conversions needed because your volume is centimetre cubed, your density is grams per centimetre cubed, so your mass is going to be in grams. Question 9. So bug the equation again. Calculate the mass of iron melted. So you put a box around the word mass. You are given the energy, but it's 5 megajoules. So you've got to know what these symbols stand for. So it's 5 megajoules, which is 5 million joules. And you're given the specific latent heat of fusion of iron, 272 kilojoules per kilogram. And again, that is 272,000 joules per kilogram. So you're going to use energy equals mass times specific latent heat. You are given the energy. 5 megajoules is 5 times 10 to the 6 joules equals the mass multiplied by specific latent heat, 272,000. So your mass is going to be 5 times 10 to the 6 divided by 272,000, and that comes to 18.4 and the unit is kilograms. Okay, so high demand questions. So worth more marks, but you just go through the same system as we've been doing. So a piece of solder is melted by 300 joules of energy. So you're trying to find out what its volume is. So put a box around the quantity that is asked for. You're given the density and you're given the specific latent heat fusion of solder. Again, you've got to notice that it is in it's 59 kilojoules per kilogram, which is 59,000 joules per kilogram. And again, you've got significant figures to think about. So you're going to use energy equals mass times specific latent heat. You put your numbers in. Energy is 300 equals the mass times 59,000. So you find your mass, which is 5.084 times 10 to the minus 3 kilograms. You've got to be careful here because your density is given to you in grams per centimetre cubed. So the best thing to do would be, because you've got to work out the volume, best thing to do would be to convert your mass in kilograms actually to grams. And you do that by multiplying by 1,000, so that is just 5.0847 grams. Notice that I'm not rounding it up because I've got to substitute this mass into the density equation in order to find the volume. So I now use density equals mass over volume. My density is 8.79. My mass I've just worked out is 5.0847 divided by the volume. So to get the volume, I'm going to have to multiply up to that side and then divide both sides by 8.79. So I'm going to do 5.0847 divided by 8.79, and that gives an answer of 0.578 centimetre cubed. But the question is asking for two significant figures, so the final answer is going to be 0.58 centimetre cubed. Question 11 is a real tricky one. So you've got to really think about it. So you've got water in a kettle that starts at 20 degrees C. The total thermal energy, and that's a clue in this question, the total thermal energy needed to boil the water and then boil the kettle dry is 519,200 joules. They give you the specific heat capacity of water and they give you the specific latent heat of vaporization of water, but again you've got to be careful because that is in kilojoules per kilogram, so you can write it out next to that number. That is that value in joules per kilogram. You're actually going to find the mass of water in the kettle. So the main thing that you've got to think about is that the energy that they give you, 519,200 joules, that is equal to the energy needed to heat the water plus the energy needed to boil or vaporize the water. So it's equal to mc theta, the energy needed to heat up the water, plus mass times specific latent heat, the energy needed to boil the water. Now, you're trying to find the mass. So one thing that you can do is take the mass out of some brackets, if you like doing it in this way. So I would take the mass out of the brackets, that is equal to, like that. So use your skills that you've learnt in maths. You know that the energy is 519,200 joules equals the mass that you're trying to find. Keep your brackets in. C is the specific heat capacity, so that's 4200 times, now the temperature rise to heat up the water, it starts off at 20, it's obviously got to get to 100 before it starts boiling. So that is 80 degrees C plus specific latent heat of vaporization, which is 2260 kilojoules. So I'm going to write that as 2260,000 joules. So you need to work out what this is. So when you do 4,200 times 80, that is equal to, because 4,200 times 80 is 336,000 plus 2260,000. So you then work out what that is, what that comes to, and that comes to add those two together, it comes to 2596000. So then to work out the mass, you've just got to do 519,200 divided by 2596000, and when you work that out, you get 0.2 kilograms. Okay, so the next one. This is a really tricky one because it's about density, but you've got a regular object, but this time it is a cylinder. So don't be afraid of drawing a cylinder at the side of the question to try and help you with it. So you've got a cylinder of granite raised from a rock sample core. It's got a diameter of 8 centimetres and a height of 0.8 metres. So straight away you've got a difference in your units to notice. You've got centimetres and you've got metres. You're given the density of granite in grams per centimetre cubed. You're going to find its mass and 3 significant figures. So the easiest thing to do would be to convert, because your density is in grams per centimetre cubed, you want to convert your height into centimetres. So 0.8 metres is the same as 80 centimetres, and that is your height. You've got to know your formula for the volume of a cylinder, which is pi r squared h. You know the diameter is 4 centimetres, so you know that your your diameter is 8 centimetres, so your radius is going to be 4 centimetres. So first of all, work out the volume of the cylinder. So it's pi times the radius squared, which is 4 squared, multiplied by the height, which is 80. And that comes to 4021.2, and it's going to be in centimetres cubed. You can now substitute that volume into the density equation. So density equals mass over volume. You're given the density, 2.75, equals the mass divided by your volume that you've just worked out. So to work out the mass, you're going to do 2.75 times 4021.2. That gives you 11058 grams, and they want it to 3 significant figures, which is 11100 and the unit grams. Okay, so let's look at the next question, final question on these. So this is also quite tricky. So if you read through it, kettle containing water is placed on a mass balance. Kettle is connected to the mains and switched on until it boils. At this point, the mass of the balance is 1.276 kilograms. It's then heated for 2 minutes, and the mass balance now reads 1.180 kilograms. And you're given the power of the kettle is 2 kilowatts. You are asked for the specific latent heat of vaporization, so put a box around that. So you know that you're going to have to end up using energy equals mass times specific latent heat, but you don't know the mass. And you don't know the energy. So you've got to be able to work out both of those things. So the first thing to do is to work out the mass. How much mass is lost on the balance as the water is boiled away? So your mass is going to be 1.276 minus 1.180 and that mass is going to be 0.0960 kilograms. So you've worked out your mass. You then got to work out the energy. But you're not given the energy, you're given the power, but you're also given the time. So you should immediately think, right, I know how to link those two together. I'm going to use energy equals power times time. So my power is 2 kilowatts, so that's 2,000. The time that the kettle is on is 2 minutes, which is 2 times 60. And so my energy is 240,000 joules. So I've now got everything that I need. I'm going to use energy equals mass times specific latent heat. I know my energy, I've just worked it out, 240,000. I know my mass, which I worked out from taking one mass away from the other, 0.0960 times specific latent heat. And so your latent heat is 240,000 divided by 0.0960, and that gives you 250,000. And let's put that into standard form to make it easier. So it's 2.5 times 1, 2, 3, 4, 5, 6. 2.5 times 10 to the 6, and the unit is joules per kilogram. And there's an extra question down at the bottom. Why might your answer be bigger than the true value, which is 2.26 times 10 to the 6 joules per kilogram? And the answer is because some of the energy transferred from the heater goes into the surroundings rather than the water. So in other words, the mass is too small in the calculation, and so the specific latent heat ends up being too big.